I'm going to say we don't have any questions with the homework. 54 and 56. Let's look at 56 quickly. So 56 gives you this equation for the population of New York, right? And it says P of T equals 19.875 over 1 plus 57.993e, and then all this decimal to the t power. All right, so let's look at it. Okay, so there it is, kind of. And it says it starts in 1800, okay? So if it starts in 1800, then you're talking about what was the population of New York in 1850, right? So obviously that's 50 years after 1800. So you're just plugging in 50 right there. That's it for that. B says, what would the population be in 2010? Well, that's 210 years after 1800, right? So you put in 210 here. And again, I'm going to type this right into my y equals, go to the table, all that good stuff. And then maximum sustainable population. Well, remember, our whole rule with logistic functions is this is your top asymptote. So that's it, all right? So that means 19.875 million is your highest value you can have. All right? All good, Sebastian? Baby? Anthony's back. Good to see you, man. Or see you chat, at least. Okay. All right. So let's get started. Make sure you have that title down, Exponential and Logistic Modeling, with that fancy pyramid-looking thing. And let's get started. All right, so we're going to do a lot of modeling, meaning a lot of word problems and all that good stuff. And that equation right there is kind of our key one. It's just an exponential function like we talked about last time, but now you have some kind of titles with it, right? So it says P of 0 first. Right? P of 0 is the initial population. That's how much you have at first. 1 plus the rate, right? That's the rate as a decimal. So if it's like 50%, that's 0.5, 30%, 0.3, all to the power of t, right? T obviously is your exponent. T is the amount of years or days or whatever they give you. All right? So when you're done writing that down, please tell me in the box so I know when to move on. Thank you. Thank you, Colin Thomas. Thank you, Sammy, Cheyenne. Thanks, Johnny, Emma. Thank you, Wadley. Thank you, Joseph. Thanks, Leilani and Kalea. And Kayla. Okay. I don't know if that's everybody, but I feel like that's, thank you, Devin. You writing it all down again, Anthony? Let's move on. All right. So what we have to start is pretty simple. All right. So you have, we got this equation the other day from San Jose, and this was done with our exponential modeling that day. But you have the equation for the population of San Jose. You have the equation for the population of Detroit. All I want you to do, spend a minute, maybe two. I want you to label what the initial population was in San Jose when the study started. And then I want to know what the growth rate is or the decay rate, either way. All right, think about that, right? You have the initial population times 1 plus r to the t power. All right, so it's very simple. Think about and write the growth rate, please, as a percent. Okay, write it as a percent, please. All right, so just knock out San Jose, please. Should take you a very short amount of time, maybe a minute. Tell me when you're done. Thank you guys for responding so far. Again, you're finding the initial amount and the growth rate. Curious how many different ways, Sammy, can get done to us. We got 2 capital letters last time. This time we got spaced out letters. We will see. Thanks, Nicole. Thank you, Devin. All right, Wealthy. All right, let's talk. So basically, very, very simple, right? This is your initial value, period, the end, right? So that's how much when the study started. But now we're saying this in here is 1 plus R, right? So we're just taking 1 away from this. So R is equal to 0.0064. 00, my goodness, 64, right? But we want to write it as a percentage, we said, so we're going to write that as 0.64%. All right, so it's a pretty small percentage, but it is still a growth rate. All right, moving on. We have Detroit. And just looking at this right away in the text box, please, just tell me what's the difference of what's happening in Detroit here. If someone wants to get on their audio, you're more than welcome to. Someone's in there. Yes, great job, everybody. It's decay. So what are we doing? We're taking 0.9858 minus 1, right? 0.9858 minus 1. Okay, and we're going to get a decay rate of, so this time, we're going to get negative 0.142, I believe. All right, so a 1.42 decay. Okay. That should be very easy, very simple. Any questions there? I'm thinking not. Let's move on. Okay, so we have a word problem here, and the title got a little messed up, but let's read it together. It says, modeling an exponential function. On his first day of hunting on the Oregon Trail, Jeffrey can hit 2 squirrels. He is improving his hunting skills at an exponential rate of 19.3% per week. Write the exponential function for Jeffrey's hunting success. How many squirrels will Jeffrey hit in 6 weeks? When will Jeffrey finally hit 10 squirrels? So we have an exponential model, and I want you to first do A, please. So tell me when you're done. All you're doing is writing the equation. You have the initial, you have the rate. This should be very, very easy. Knock that out, please, next 30 seconds. And there's a t there. If you can see it, there it is. All right, so you have h of t. I just use h of t. You don't have to. I mean, you can use y. You can use p of t. I just use h like the hunting. So how many squirrels he hunts out of the h value. But anyway, h of t equals 2 times 1 plus 0.193, 19.3% to the t power. All right, so that was the answer to A. Hopefully everybody has that, and let's go ahead and work with it now. All right, part B, how many squirrels will Jeffrey hit in 6 weeks? Very, very simple, right? Of course, time is the t value. So go ahead and plug that in. Make sure you have your calculator. Tell me when you're done, please. Thanks, guys. All right, looks like most people are done. There's a lot of things you can do. I'm just going to go to the table. Let me minimize this. I'm going to go to the table and get my answer. Now, the question, we had this morning, and it's a good one because we're talking about animals. You shouldn't really round up in this case. If you want to say 5.7, you could, 5.8 with the round, or you could just cut it off and go to 5. But, with any kind of people or things like objects that can't be cut in half or decimalized, that's a word, 5.76 or, 5. All right, so that's it. Moving on. When will Jeffrey finally hit 10 squirrels? When will Jeffrey hit 10 squirrels? So now we're plugging in 10. I don't know why it came back to me. Plugging in 10 right here. Okay, so the proper way to solve this is with logarithms. But because we haven't learned that yet, we're not going to worry about it. We're going to talk about what we did last class, which is just put this in y1, put this in y2, right, and find the intersection. You can also divide by 2 first if you wanted to, make your life a little bit easier, but that's up to you. All right, so again, spend another minute, please. Go ahead and find out what t will equal when Jeffrey's going to hit 10 squirrels. Thank you. Good. Yeah, because we saw it later in the lesson too, right, Melanie, where you have to do the same kind of thing. Obviously, hopefully that unlocked in your mind what you needed to do. But all you're doing, anytime they want to know like how much, or like when something happened in these problems, that's pretty much always going in y2 on the other side of the equation. All right, Devin. This is good window practice. Make sure you get the correct window when you go to graph here. Remember, x is the time. So, it's got to kind of be logical. I mean, you're not going to talk about like 5 million weeks or anything like that, right? So I just made my window 0 to 30 just to be safe. I made my y window 0 to 20 because not even it was too big, but I know that I need to get to 10. So I was going a little bigger than 10. Could have done 15, could have done 12. I did 20. Again, tell me when you're done. Thank you, Emma. Thanks, guys. Thank you, Kayla, Thomas, Wadley, Nicole. Sammy, what do we got? We got a little box for the end there this time. All right. That's what showed up on my screen. Thanks, Johnny. All right. So you go through this and you graph both and you find the intersection and you get 9.12 weeks. So just about over 9 weeks, Jeffrey can finally bring home 10 squirrels to his family to feed. All right, so that's where we're at. All right, let me know if you have any problems with that, but hopefully that was pretty good. Let's keep moving. Oh, there's the visual of Jeffrey hunting, in case anybody was wondering. He's looking hard. That is an official screenshot from Oregon Trail. All right, so it says suppose a culture of 100 bacteria is put into a petri dish and the culture doubles every hour. Predict when the number of bacteria will be 350,000. So this is a lot like question C of the part C of the last question. But your job here, again, is to make sure you understand how to write this equation. The whole thing is going to be, can you get the rate? If you can get the rate, you're going to be good. Can you get the rate correctly? So spend a minute, think about that one. Think about how you're going to correctly write the rate. This is 1 plus R, right? So think about what the rate is. Go. Again, your job is to answer the whole question, but make sure you have that rate correct. We can go over that here in a moment. Let me just type something in my calculator quickly. Thanks, Colin. All right, let's make sure we're on the same page here. We talk about the rate. All right, it's doubling. So what happens if you double something? Well, like right now, like I did this morning as well, right? I have one marker in my hand, and now I have two markers in my hand, right? So I doubled it. So what was my rate of increase? Right, my rate of increase is 100%, right? I have 100% of what I had originally added to it. So our rate is 100%. How do we write that as a decimal? We just say a whole number 1, right? That's it. So there's your equation right there. All right, so y equals 100 times 2 to the t power. Okay, so there's our equation. And now we want to know, when is it going to be 350,000? Well, that's the exact same question as part C of last question. So that's all we're talking about. You can't see me? All right. I can still see my camera, so let's see. Okay, Melanie can. Okay, so the camera's still on. All right, Colin, reset yourself there, Colin. Yeah, back to it. All right, so we're putting in 350,000 right here. And no parentheses there. Equals 100 times 2 to the t power. All right, so you can go to your calculator right now if you want. Again, we talked about this morning. You can make this a little simpler. What could you do to both sides here? Anybody out there? Yep, we're going to divide by 100. You don't have to do this, but it makes your life easier. So we can cancel 2 to the 2's. So, or 2 to the 2's, 2 to the 0's. 3,500 equals 2 to the t power. All right, so again, this is just great calculator practice. Go ahead and put this in y1, put this in y2, fix your window. You should have an intersection point for your answer here in probably, I don't know, a minute. Glad you can see again, Colin. There's the graph with my window. Make sure you're getting something like that. I'll put the answer up in a minute. Make sure you can get that picture of some sort. With the window, Sebastian? Just use X. Sorry if that confused you. X and T are the same. Cousins, maybe. What do you think, Sammy? I mean, for X, I don't know the answer, what the answer can be, but I'll just be logical, like 0 to 30, 0 to 40, something like that. And then for Y, this is your, what you're looking for, right? So you got to be a Y value bigger than that. So I think I just used 4,000. Make sure you kind of adjust your window And again, had you use this, obviously you need to be like 400,000. But, well, that wasn't on the screen, but like 400,000 for that. But again, because I use this, I'll use 4,000. All right, so make sure you get this answer here. I'm going to put it up right about now, actually. Can I get the right lighting? There it is. Okay, 11.77 hours, right? This was every hour. And I just disconnected. Well, that wasn't good. I know I got disconnected. You guys still out there? Okay, thanks. So, hopefully you saw that before I got disconnected. Sad story. It happened to me this morning twice, I think, too. I'm going to fix my camera here in a minute, but remember the answer is 11.77 hours there. Okay, 11.77 hours. Let me try and fix my... Actually, before I fix my camera, you can start this next problem. Okay, so you have the half-life of a radioactive substance is 20 days, and there are 5 grams present initially. On the time when there will be 1 gram of the substance. That's a little bit tricky. I'll be back in a second. Hold on. Sad story, isn't it, Melanie? I'm back. All right, can you see me again? Beautiful. I got this. I got the trick, and when I get knocked out, I can get right back. That is the positive. The negative's getting knocked out, but at least I know how to get back. Thank you. All right, so let's talk about this one. All right. Oh, there you go, Sammy. Always waiting on Sammy's explosive versions of basic words. All right, so suppose the half-life of a certain radioactive substance is 20 days. There are 5 grams present initially. By the time when there will be 1 gram of the substance remaining. That's some chemistry. You know the ideas of a half-life. But even if you don't, it doesn't really matter, right? We're just talking about you're going to have half of the substance, basically, in 20 days. All right? So, a couple things to talk about. First is the rate, right? Basically, the substance is getting cut in half for all our purposes. So think about what the rate's going to be. And then it's only happening every 20 days. It's not happening every day. We want to figure out how many days it will take to get to 1 gram of the substance. So, you got a little bit to think about here. It's not crazy, but think about what you have to do with the 20. All right, I'm going to give you a minute to think about it. And we'll come back in a minute. All right, think about what you got to do with that 20 especially, both the rate and the 20. All right, let's make sure we're on the same page here. So we know we have 5 grams present initially. All right. Now the rate, let's think about it, right? Hopefully you have this already, but you're talking about every 20 days it's getting cut in half, right? So it's a 50% kind of decrease, but we're going to say 1 minus 0.5, which leaves us with 0.5, or actually like 1/2 better here. It doesn't matter. You can write 0.5. Okay. Now, here's the key. every 20 days. So if you just put a T up here, right, that's going to happen every day. All right, so in the text box, anybody have an idea what to do with this 20 here? Colin's on. You could actually do that, Sebastian, like off to the side, kind of tell yourself that, and then like replace it at the end. But what's an easier thing to do is just make a T over 20. So that kind of does that for you. All right, so now we want to know when that's equal to 1. Same process as last time, guys. Go ahead and answer that. Tell me when you're done. Again, make sure you respond when you're done. We got 2 people in there so far. Good window challenge as well, compared to where we were. No! Got knocked off again. Yeah, the window is tricky for some people. Well, let's think about it before I get my video back. Your x, again, you're not going to know your x exactly, but just be logical. I mean, it's talking about what, days, right? So, I mean, you could go to 100 days if you want. You could go to, but figure if it's going to be like 780 days, they would do years instead, right? They wouldn't do days. So I would just go like 0 to 50 or 0 to 100 probably to start and see what it looks like. And then for y, for y, it's actually very easy, right? Because that's the y value. I just pointed at the board like you can still see me. Just kidding. You can't see me, but you can hear me. So the y2 is 1, right? So you need to be bigger than 1. That's it. So, you can make it 3, you can make it 5, you can make it 10. But either way. All right, let me get my video back, and then I'll show you my window. Okay, assuming you can see me again, because I can see myself on there. The graph looks like that, and I'm going to find the intersection, 1, 2, 3, and get that answer. 46.438562, 46.4 days until the substance is just 1. And this was my window. Again, not mandatory to be that. That's what I got. All right. If you're good, tell me you're good in the box, please. 46.4 days is fine, Sebastian. I mean, you got to just keep thinking about it. It shouldn't be bad. Thank you, Kayla. Both Kaylas, thanks for responding. Thanks, Sammy and Nicole. I think you do. I think you're a capable window setter. Yeah, Zoom Fit's fine. Sometimes Zoom Fit will lead you astray, but it's fine. All right, let's move on. So we're almost done here. We got 2 more problems. One is our old friend regression. So make sure you have your calculator in. You're going to go remember stat, edit, all that stuff before you start. Go to, well, let's just look at it. This study starts in 1900, right? So make L1 start at 0, right? Make basically T or X or whatever. In this case, L1 start at 0. 1910 is 10. 1920 is 20, and so on. For L1, obviously type in L2. All I want you to do now is find the equation. You should get the points, get the whole thing like we're in class. If you don't have a graphing calculator, let me know, and I can send you a link to a calculator online. Otherwise, get going, please. Remember, we're doing exponential regression here. Yep, that's right. Yeah. All right, so keep going, but I'm not going to minimize the numbers yet, but you should get something like that where you have all the points. All right, so. All right, so again, make sure you get the equation. And then here's the question I have for you. The question is, what is the prediction for 2007? We have the actual number for 2007, 301.6 million. I want to know what your prediction, when I say yours, our prediction would be, and how off it is, basically. So figure out how wrong is our prediction based on our model, all right, for 2007. Tell me when you got it or if you have a question. Devin, I got your thumbs up. On this one, when you get your answer, type it into the box, please, to the hundredth, to 2 decimals. But depending on how you rounded the B value, you might be a little different. I'm just curious how everybody did. So don't feel bad if you're a little bit different than someone else's. Obviously, just go ahead and type in your answer in what our model says for 2007. All right, what our model says for 2007 when you get it, and then you can think about how far off we are. But type in what you got, please. Yeah, depending on how you round, because exponentials are very sensitive. So if you round a lot or round a little, you're going to get very different answers. I wrote it as 1.012698, and I got 312.65 basically. So again, that doesn't make me right. I'm not saying that. I'm just saying like everyone's going to be a little different depending on how you round. Obviously, on a test, I would tell you how many places to round it to or whatever. But just type in what you got. Don't feel self-conscious about it. Just whatever you got, type it in, and we'll go from here. Thank you, Nicole. What's wrong, Anthony? Okay, good. All right, man. Have a good day. Good weekend, all that good stuff. Enjoy your isolation. All right. Hopefully you have this. We didn't get everybody's answer, but make sure you communicate with me, please. But again, I'll just put my answer I had on the board right now. All right, that's my answer, 81.04. And again, I could have done better too in terms of my rounding, but that's what I went with. All right, so again, without being on the same page with our rounding, we're going to be a little bit off, but that's it for regression. All right, we're moving on. We're just about done. Time is at 1:48. Perfect. We should be done by 2. All right. We're not going to do that one. All right. So here is our last problem of the day. Does not take all that long. It says Watauga High School has 1,200 students. Bob, Carol, Ted, and Alice start a rumor which spreads logistically so that S of t equals 1,200 over 1 plus 39 times e to the negative 0.9t. that models the number of students who've heard the rumor by the end of day T. A, how many students have heard the rumor by the end of day 0. B, how long does it take for 1,000 students to hear the rumor? All right, we had a little good time this morning. I need suggestions on what the rumor is. That was our thing in the morning. We had a bunch of rumors thrown at us here. So if you have an idea of Adele's coming, Melanie, don't pressure me like that. Good. I love. Was that JoJo Siwa or whatever the calendar was? That's what you're talking about? All right, absolutely, sure. Come on, where's our personality in this afternoon session? We have no ideas for a rumor. They were flying in this morning. And yes, I have Adele for you. If I can figure out what I was doing. All right. Well, since you guys don't want to talk, that's okay. So do the problem at least. So I would say this. Type in your logistic model to Y1, please. And go ahead and answer that question for me. There you go, Gianni. That's a positive rumor there. All right, Colin. Thanks, man. I tried, man, and again, this is a very specific one for the problem. No, I lost my video again. I'm trying. Thanks, Emma. Let's see. took a minute there, Colin, huh? Hey, Dora. All right, I'm back. So we had two questions. How many students have heard the rumor by the end of day 0? How long to take 1,000? So, wrong button. All right, so here's just my regular logistic curve, the spread of the rumor. And remember, that top number is the most kids that can hear it. So that means there's 1,200 kids at the school. And we will have 2 questions. End of day 0. Well, you have a couple options. You can do this by hand. You can use the table. I'm going to use the value button here. I'm just going to hit second trace value, and it's going to tell me that 30 people knew it at the end of day 0, basically. So when the rumor started, 30 people knew it. All right, and then we're going to say we want 1,000. We've been talking about this all day. So we're going to say Y2 is 1,000. See if I can type like this. And we're going to go second trace, intersect, enter, enter, enter. And there we go. There we have it. 5.85 days. That rumor's flying. 1,000 people. 1,000 people knew it in 5.858884 days or whatever that is. So about 5.6 days or 5.9 days, excuse me. 5.86, what I was looking for. All right. So that is the spread of the rumor. Nosy school indeed. Anybody have any questions out there? I'll give the chat box a minute. Not a very talkative group today, though. I'll tell you what. $30. Yes. We'll talk about that right now. All right, so here's the deal. As Melanie's still in here, I think so. Yep, Melanie's still here. I was just curious. As I told the first period, but the morning session, we have morning, afternoon, AM, PM here. I decided, since I'm in charge of school now, my own school, every Friday is going to be a teacher work day for us. So you have no class on Friday. So that means that's just good news. That's all. That's the only thing there is to say about that. I will probably be doing some work, but not that much work either, honestly. I'll make sure Monday's lesson's ready. So we are back on Monday, 10 and 1 again. Come to either one. You do have an assignment. I think it's due Sunday night. I believe it's in, or both, honey. I believe it's in, I know it's in the assignment tab. You can upload it. If you haven't uploaded today's yet, make sure you get that in. And that's about it. If you have nothing, I have nothing. Have a terrific weekend. Stay socially distant out there somehow, some way. And I don't know. I got nothing else for you. So have a wonderful time, and I will talk to you soon. Message me anytime on Teams, on Canvas, email, if you're ever unsure of anything. And again, all these lessons will be saved if you ever need to go back. All right? So I'll let the text box kind of blow up for a second. Thanks, Thomas. You too, Emma.